This is an example of a parallel circuit. We can identify the circuit pretty easily by coming out to following the circuit out this way. As the electricity comes out and goes along the line, when it gets to this point right here, the electricity can go down and then it continues across like this. So it has more than one path for current to flow. So that right there is where it becomes a parallel. So this is a parallel circuit. We have two resistors in the circuit. And what we're trying to figure out is what the voltage drops are on resistor number 1 and resistor number 2. So, and we also need to figure out what the amperage is on resistor number 1 and resistor number 2. So if we fill in our known values, we can start there. So 12 volts, because this is our known value for 12. We know what our resistance values are. So that's 12 ohms here and 12 ohms here. And we know what our amperage total is. It's right here. So that's 2 amps. Now, there's a couple of ways that we can figure out the resistance value, or the resistance total. With a parallel circuit, there's certain things that don't apply anymore that did apply in series circuits. You remember in a series circuit, amperage was constant. Well, in a parallel circuit, amperage is additive, but voltage is constant. So we know our voltage total, we can add that voltage to the other two resistors because voltage is going to be the same all the way through the circuit. So now it's a matter of just doing some simple Ohm's law, and we can figure out what the rest of the values are, and that way we can double check ourselves as well. So if we use Ohm's law, we can go 12 divided by 2 gives us 6 ohms of resistance. And according to this, resistance total, if you remember the law in a parallel circuit, resistance total is less than the smallest resistor. So in this case, both of our resistors are 12 ohms, so 6 volts needs to be is less than either one of those. So that sounds like it's pretty right. So now we can continue double checking ourselves by doing some more Ohm's law. So 12 divided by 12 is 1 amp. And then 12 divided by 12 is 1 amp. And if we add the amps together, because remember amperage is additive in a parallel circuit, 1 plus 1 equals 2. So that's how you can double check yourself. Now, like I say, this one here was fairly simple. We could figure out what our amperage is on these because we have two resistors of the same value. Another way you could figure out your resistance total, instead of doing Ohm's law this way, what we could do is we could use the same value method and do it this way. So the same value method means that we have two resistors in the parallel circuit and they both are the same value. So you take the value of the resistor, which is 12, and you divide it by how many resistors there are. So you divide it by 2 because there's two resistors. So we have a value of 12. We divide it by the number of resistors, and so that equals 6. In this case would be ohms. And so that's another way that you can calculate the resistance. Another way you can calculate the resistance is by using a scientific calculator. So if you have access to a scientific calculator, we all have our cell phones. And so if you take your cell phone and pull up the calculator and then turn it sideways, you have a whole bunch more stuff that shows up on your scientific calculator. And so if we do that, if you look around here, if you've got a 1 over x key, so in this particular case, I know you can't see it very well on the video, but there's my 1 over x key right there. So I can easily add up my resistance using the reciprocal sum with a 1 over x key. And the way you do that is you say 12 1 over x plus 12 1 over x equals, and here's the most important part, you got to hit the 1 over x one more time. You hit the 1 over x one more time, we have 6 ohms. And so that's the same that we've done here. There is another way.